All right, here's week 2 of pre-calculus. We have a review day, chapter test, and then 3 assignments. So this is actually what we would have been doing this week. So now we're caught up to where we should be at. All right, well, there's the review set. So there isn't much to write. I guess I could give you down at the bottom, I wrote down the topics that are on the test. Again, I start them if there's multiple questions. Complete cumulative frequency chart and graph, median and specific scores from the graph. So finding the median from the graph and maybe the 10th percentile or top 50th percent. Find the total mean from subset, standard deviation, algebraic problems dealing with the mean, mode, and range, median, mean from a frequency chart. Okay, so you have a chart and you have to find the median and mean. That's where you make the product column and the cumulative frequency column. Q1, Q2, Q3, and the IQR, and then interpreting box and whisker and histogram and cumulative frequency lines. So matching them together. So that's Monday. Now I'm going to give you the test. And you'll probably have to freeze the video to read the questions a little more carefully. There's page 1. First problem goes all the way to page 2. Page 3. Page 4. Page 5. Page 6. Page 7. And the final page. And now I'm going to give you the answers. Now, especially like the first one, this is just a sample graph. I don't even know how well you can read it, but there really is no answer key for the first one. It's just basically where you put the lines. So these 3 answers could have a wide variety of answers. So these are not the best answers either, right? So it'll be based on your graph. So you use your graph. So I wouldn't even write these down. So I'm not even saying these are the best answers. This one could have multiple answers. I don't think we had a number 10. Okay, so that was the test. Now we're going to start chapter 21. Correlation. This is a short chapter. I think all we have is a test for chapter 21, which would be next week. All right, correlation is the relationship between two variables. When we make a graph, the y-axis is where the dependent variable goes. And the x-axis is where the independent variable is. If the data is going in an upwards direction, we say the correlation is positive. And obviously, if it's going in a downwards direction, we say the correlation is negative. And if the data is all over the place, we say there is no correlation, or it is randomly scattered. If the data is fairly straight, not perfectly straight, but fairly straight, we say that it has a linear trend. So this one has a linear trend. Where this one we would say is a nonlinear trend. In calculus, we will get into more of different types of correlation. We pretty much stick to linear correlations in pre-calculus, but you can find the correlation of a logarithmic. So this looks like a logarithmic trend or a power trend. So there are 7 things that we test for in calculus, but in pre-calculus, we pretty much stay with the linear. We can also talk about the strength of the correlation, and what that means is how closely the data follows a trend. If the data is pretty close together, we would say that's a strong correlation. Strong positive if it's going up. And obviously we could have, for all these, could be going down too. Maybe make those a little closer. So pretty close to it. This would be a strong negative correlation. If the data is a little further apart, a little more spread out, we would say that's a moderate correlation. So again, you can have a moderate positive or a moderate negative. And if the data is really spread out, whoops, let's do a positive one first, but still has a correlation, we would say that's a weak correlation. And again, you can have weak positive or weak negative. We We've talked about an outlier before, basically an isolated point away from the body. Of data. So we got trend here, and then this point way over here could be called an outlier. Next definition, we have what is called causation. And what we have here is correlation between two variables. Ooh, I shouldn't be writing over there. Correlation between two variables does not mean that one caused the other. This gets a lot of people in trouble in the media. They think because there's a correlation, there's a causation, but it could be just purely coincidence. For example, let's say I did an IA and I found that arm length and running speed had a strong positive correlation. Here's two questions then. Does this mean that short arms cause a reduction in speed? Hopefully you would say no. Or do high running speeds cause arms to grow? And that's even worse. No, definitely not. So there could be other variables that led to the strong correlation. Maybe their age. Let's do another example. And this one's even worse. I did an IA where I found the number of TVs sold and the number of stray dogs collected had a strong positive correlation. We should obviously know that one did not cause the other to occur. So there is no causal relationship here. They usually keep them fairly obvious. Let's try another example. What about the age that you are and the distance a ball is thrown? And again, we'll say it had a strong positive correlation. Does this have a causal relationship? And the answer is yes. The older you get, the further you can throw a ball up to a certain age, and then it goes back down. So I can pretty much guarantee you can throw the ball further now than you could 10 years ago. And when you get old like me, you maybe can't throw the ball as far. All right, so that's the first lesson. (21B) deals with Pearson's correlation coefficient. We will use this a lot next year in our exploration, which is basically what the IA is called in calculus. Now, yesterday we talked about how there was strong, moderate, or weak correlations. But similar to the definition of outlier, if I draw this, what is that? It's hard to tell. All right. This is hard to judge. Is that medium? Is it strong? Is it weak? You can make an argument for almost all three of them. All right, so it's hard to judge, so we basically have to guess. So we need a better way of doing this. All right, Pearson's correlation coefficient takes the guesswork out of it. We use a formula. Sigma, which means the sum of x minus the mean of x times y minus the mean of y. And then we're going to divide that by the square root of the sum of two products, which would be the difference of x minus the mean of x squared and the difference of y minus y, the mean of y squared. We will definitely use this formula. The values of R range from -1 to +1. The sign of R indicates the direction. If it's positive, it's obviously going up. If it's negative, it's going down. The size of R indicates the strength. Of the correlation. A value of R close to ±1 indicates a strong correlation. Whereas a value close to 0 indicates a weak or no correlation. Now again, we need better answers. What's close, what's far away? So we use a table. If the absolute value of R is 1, which we won't see really in this class, we say it's a perfect either positive or negative correlation. Obviously, if it's negative, negative correlation. So that's why we use absolute value, because we do want to indicate whether it's positive or negative. If it's between 0.95 and 1, we say it's a very strong, strong positive or negative correlation. That's perfect. That's pretty close to perfect. If it's between 0.87, should not be an equals on the back end. 0.87 and 0.95, we say that's a strong correlation. So each one of these diagrams, I'm just making them a little wider. If it's from 0.5 up to 0.87, we say that's a moderate correlation. From 0.1 up to 0.5, that's a weak correlation. And anything else from 0 to 0.1 would be no correlation. So now we are not guessing anymore. All right, let's do an example. We have 4 different lawns, and we are putting a chemical on each of them, or a compound. Oops. 1, 2, 4, and 5. And we measured how much the lawn grew, the lawn growth. So compound 1, 3 millimeters, 3 millimeters, 6 millimeters, and 8 millimeters. Those are the 4. And the question is, find and interpret the correlation coefficient between the 2 variables. They may just say, find R. So we can make a table. We have 2 columns of data. Call the first one X. So I put in the numbers of the compound. The second one we call Y, and this would be the growth. Now if we think of the formula, if we go back to the formula, let's see where I can write this. Right away over here. We are going to have about 3 or 4 more rows, so leave some room formula is the sum of the product of the difference of subtracting the difference of x and the mean of x and y and the mean of y all over the difference of x and the mean of x squared, the sum of that, times the sum of the difference of y minus the sum of y squared, all square rooted. All right, so if we look at the formula, probably the first thing we need to do, even maybe before we make the chart, is find the mean of x and y. I can do that down here. The mean of x would just be 1 plus 2 plus 4 plus 5 divided by 4, which equals 3. And the mean of y would be 3 plus 3 plus 6 plus 8 divided by 4, which is 5. All right, now that we've found the mean of both x and y, now we can go back to our chart. So looking at the chart, looks like the first thing we should do is subtract the x's. So x minus the mean of x. So similar to the standard deviation, we want to subtract all of these numbers from 3. So 1 minus 3, 2 minus 3, 4 minus 3, and 5 minus 3. The formula then tells us, hey, let's do the same thing with the y's. So we're going to subtract all these numbers. We're going to minus 5 from each of these numbers. 3 minus 5, 3 minus 5, 6 minus 5, and 8 minus 5. Then we're going to multiply those differences. So we're going to multiply these. Negative 2 times negative 2, negative 1 times negative 2, 1 times 1, 2 times 3. Looks like we want to add those together. That'll give us 13. So the top number is 13. We look at the bottom, we want to square the differences. First of the x. So we go back all the way to this column and square these numbers. Negative 2 squared is 4. Negative 1 squared is 1. 1 squared is 1. And 2 squared is 4. Looks like we want to find the sum of those. Oops, sorry, it's getting a little sloppy. So that 10 goes right here. And then we're going to multiply that times the sum of the difference of the y's squared. So we go to this column and we square all these numbers. Negative 2 squared, negative 2 squared, 1 squared, and 3 squared. Add those up to get 18. So there's our numbers that we punch into the calculator. 13 divided by the square root of 10 times 18. We round to 3 significant figures. 0.969. So there's our answer. And now we want to interpret that, and we look at our chart. .969 is a very strong positive correlation. I would not abbreviate on the IB test, but I can abbreviate. So what that means is this suggests the more compound the more growth. There is an issue that we only have 4, so we have a small sample. The small sample size could be misleading though. That's why in our IAs we did 150 for a minimum. You may have to fill in the table on the IB test, but if they say to start from scratch, we could do this on the calculator. Let's make sure I show this here. All right, so we're going to do the same problem, but we're going to use a calculator for it. So we're going to enter our data in a list. So we go stat, and we hit enter, and then we enter our data. First we got to clear out the data that's already in here. All right, 1, 2, 4, 5. 1, 2, 4, whoops. 3, 3, 6, 8. So we entered the data. Now we're going to go stat. Need to go to calc, so right arrow. And now we have 2 variables. So we want to hit 2. Now I think you might have something under frequency, all right? If there's something there, clear it out. All right, from last chapter we did frequency, so there was something there. So make sure that's clear. So X is L1, Y is L2. This needs to be blank.